Students, welcome back to the next session of number systems. We can solve the remaining problems at the exercise 1.3. Sixth question, look at several examples of rational numbers in the form p by q. Q is not equal to 0, where p and q are integers with no common factors other than 1 and having terminating decimal representations. Can you guess what property q must satisfy? Students, we know that rational numbers always are represented in the form of p by q, where q is not equal to 0 and p and q are integers. To form a terminating decimal representation, the denominator of a rational number always represented in the form of 2 power m into 5 power n, where m and n are natural numbers. To verify the given statement, I had given few examples to refer. That is, first example represents 1 by 2. We have to write the denominator 2 in terms of 2 power m into 5 power n. That is 1 by 2 into 5 by 5 gives a result as 0.5, which forms a terminating decimal expansion. That is, the denominator q should have the factor as 2 or 5 or 2 and 5 both. In the second example, 5 by 8, that 8 can be represented as 2 cubes. So we can write this as 5 by 8 into 5 cube by 5 cube. That is 5 by 2 cube into 5 cube into 5 cube, which is equal to 0.625. It forms a terminating decimal expansion. In that way, you can go through the remaining examples. From the given examples, we find that the decimal expansion of the above numbers is terminating. Along with, we can see that the denominator of above numbers are in the form 2 power m into 5 power n, where m and n are the natural numbers. Hence, we can conclude that to form a terminating decimal representation, the denominator q of a rational number is always represented in the form of 2 power m into 5 power n, where m and n are the natural numbers. Here we can solve 7th problem in exercise 1.3. Write 3 numbers whose decimal expansion are non-terminating, non-recurring. Students, we know that the decimal expansion of an irrational number is non-terminating, non-recurring. That is, the decimal expansion contains infinite of digits and never repeats. The digits never repeats. Here I had given 3 numbers that have their expansion as non-terminating, non-recurring decimals. By seeing these 3 examples, you can observe that the digits in the decimal expansion never repeats and never terminates. Hence, we can conclude that these 3 numbers that have their expansions as non-terminating, non-recurring decimal. Solve question number 8 in the exercise 1.3. Find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. Solution. To find irrational numbers between the two rational numbers 5 by 7 and 9 by 11, first we shall divide 5 by 7 and 9 by 11. By dividing 5 by 7, we got the decimal expansion as 0.714285 and 9 by 11 as 0.8181, which forms a non-terminating, non-recurring decimal expansions. Now we can find out 3 different irrational numbers between the decimal expansion of 5 by 7 and 9 by 11, that is in between 0.71 and 0.81. We are going to find out 3 different irrational numbers. Here the required numbers are 0.73073000, 0.765076500, 0.80800. The digits keeps going on, which forms a non-terminating, non-recurring decimal expansions. Students, now we can start solving the problem number 9 in the exercise 1.3. Classify the following numbers as rational or irrational. To classify the numbers as irrational or rational, we need to apply the condition of rational or irrational. That is, the decimal expansion of rational number is always terminating and non-terminating recurring, and the decimal expansion of irrational number is non-terminating, non-recurring. First question, square root of 23. 23 is not a perfect square. Hence, we can say that square root of 23 is an irrational number. Students, in the square root, if you are having any non-perfect square number or a prime number, you can say that given number is an irrational number. In the second question, square root of 225. 225 is a composite number. So you have to find out the factors of 225 using prime factorization method. By finding the factors using prime factorization method, we got the result as square root of 225, which is equal to square root of 3 into 3 into 5 into 5, which results as 15. Thus 15 forms an rational number. Like these 2 problems, you can solve the remaining sums as an home assignment. Let's learn successive magnification method on number system. Before that, we will learn how to locate the point on the number line. To locate the decimal point on the number line, we use magnifying glass. Such method is known as successive magnification method. Let's understand this by solving the following example. Represent 2.4 on the number line using successive magnification method. For that first step, just draw a number line and represent the positive and negative numbers on it. The second step, we will identify where the given number lies. In this particular, 2.4 lies between 2 and 3. So let's focus the portion between 2 and 3. We'll divide this portion into 10 equal parts, that is 2, 2.1, 2.3, etc. up to 2.9, 3. In the question, they ask you to locate 2.4 on the number line. The last step, so you locate 2.4 on the number line. Students, we can solve the problem number 1 in the exercise 1.4. Visualize 3.765 on the number line using successive magnification method. Solution. I had given the figure to illustrate this condition. First step, draw the number line and represent the numbers on the number line. We can understand that 3.765 lies between 3 and 4. As a part of step 1, we can understand that 3.7 lies between 3 and 4. Let's divide the portion between 3 and 4 into 10 equal parts, that is 3, 3.1, 3.2, etc. up to 4. Hence, we know that the numbers 3.7 and 3.8 will lie between 3 and 4. This illustrates the first number line on your figure. Step 3. If you observe after the decimal point 3.7, we have to focus the portion between 3.7 and 3.8. So let's divide the portion into 10 equal parts, 3.7, 3.71, 3.72, etc. up to 3.8. From this, we know that the numbers 3.76 and 3.77 will lie between 3.7 and 3.8. You can see the second number line in the given figure. Step 4. If you observe after the decimal point 3.76, we have to focus the portion between 3.76 and 3.77. So let's divide the portion into 10 equal parts, that is 3.76, 3.761, 3.762, etc. up to 3.77. From this, we know that the numbers 3.764 and 766 will lie between 3.76 and 3.77. Step 5. From this, we can locate 3.765 on the number line. From this, we can conclude that 3.765 will lie between 3.764 and 3.766. Hence, finally, in the figure on the number line, third number line, we can conclude that we need to use the successive magnification method to locate 3.765 on the number line. Second question in the exercise 1.4. Visualize 4.26 bar on the number line up to 4 decimal places. Here I had given the figure which illustrates how to locate 4.26 bar on the number line up to 4 decimal places using successive magnification method. Students, please go through this figure, how to locate and visualize 4.26 bar on the number line up to 4 decimal places. Students, we came to an end of this session. In this part, we learned to solve the problems in the exercise 1.3 and 1.4. Thank you.